Welcome to this explainer. Whenever we see a massive, multi-billion-dollar industrial plant going up, it's easy to just marvel at the towering cranes, the miles of complex piping, and those colossal steel vessels. But today, we're going to look right past all that exterior steel. We're going to treat these massive industrial machines like a newly constructed house that needs a meticulous final polish before the owner finally moves in. Our focus today is on a highly specific, totally fascinating phase of plant construction: equipment internal cleaning.
So I want you to think about this for a second. What's the most critical, yet completely overlooked step before actually turning one of these giants on? Everyone's looking at the huge steel beams, right? But the real secret to a successful, safe launch is actually hidden completely out of sight on the inside. You can have the most perfectly engineered facility on the outside, but if you don't take care of the internal environment of your equipment, you are setting yourself up for an absolute disaster.
Here is the basic rundown of how this timeline works. First, we have the hydrostatic pressure test for the piping. Then, the line flushing. And right there at step 3 is our main focus: equipment internal cleaning. After that comes the box-up inspection. And finally, handing the whole thing over to the owner. Now you might be wondering, why on earth do we need to clean a brand new machine? I mean, if it was just manufactured, shipped, and installed, shouldn't it literally be spotless inside? Why dedicate an entire phase of construction just to cleaning it? It's a totally fair question.
Well, the reality of a chaotic, bustling construction site is kind of staggering. When they flush out those connecting pipes, a ton of debris gets washed right into our pristine equipment. And honestly, human nature plays a huge part here too. Workers sometimes use these giant open machines as a super convenient trash can. No joke, it is surprisingly common to find discarded welding rods, dropped hard hats, empty water bottles, and yes, even someone's forgotten pair of shoes deep inside these massive steel vessels.
So, imagine for a moment the project is running behind, the owner is getting incredibly impatient, and we decide, you know what, let's just skip this internal cleaning. We leave a stray welding rod, some random debris, or a shoe inside a massive reactor. What is the absolute worst that could happen when we flip the switch and highly pressurized, volatile chemicals start rushing through? The short answer? Severe, catastrophic damage to the entire process. We aren't just talking about a minor clog here. Even one single piece of foreign material, like a hardened welding rod, can be swept up in a high-speed flow and turn into a deadly projectile. It'll violently shatter delicate internal components, completely destroy expensive pump blades, and literally bring a multi-million-dollar plant to a grinding, screeching halt. The financial and safety implications are just massive.
Because the financial stakes are so high, humans have to physically crawl inside these dark, cramped spaces to clean them out by hand. But obviously, human life is way more valuable than equipment. Entering these machines is a confined space entry, which is inherently dangerous. So, the absolute first thing we do is a rigorous gas check to make sure there are no toxic gases and that there's plenty of oxygen before anyone even thinks about stepping a foot inside.
But just testing the air once isn't enough, right? We have to keep those workers safe the entire time they're in there. So we use a life-saving procedure called isolation. This literally means blocking off all connecting pipes with heavy steel plates known as blinds. This way, if someone in another part of the plant accidentally turns a valve, absolutely no toxic chemicals or boiling fluids can accidentally flow into the space while our team is working.
And this just shows the incredible lengths we go to for safety. We are constantly pumping fresh external air directly into the machine the entire time. Workers climb down temporary ladders deep into the belly of the equipment to meticulously scrub, sweep, and remove every single piece of trash, right down to the absolute last speck of dust.
Now this part is really fascinating. These workers, they aren't just a cleaning crew. While they're in there scrubbing, they also perform a crucial internal installation check. They are literally the final set of eyes inside the machine. They have to verify against complex engineering drawings that all the internal pipes and specialized parts are actually installed, and installed correctly with the right bolts and the exact right gaskets before this machine gets sealed.
Once the crew is done cleaning and checking the parts, official inspectors step in. And let me tell you, they are incredibly meticulous. They use strict line-by-line sign-off sheets to verify the safe isolation, confirm the internal parts, and shine their flashlights into every single corner to guarantee absolute cleanliness. They are this rigorous because they know this is their absolute last chance to ever look inside this equipment before it goes live.
Which brings us to a fantastic industry term: box up.
Once the inspector finally signs off, we box it up. This literally means closing the equipment doors for good. It signifies the end of the internal work. No more tools, no more ladders, and absolutely no more humans will enter this vessel for the rest of the construction project. The machine is officially clean, verified, and ready to become a closed system.
The doors we're actually closing are called manholes. They're these huge, heavy, circular steel hatches on the sides of the massive tanks. Once these hatches are swung shut and bolted down super tight during the box-up phase, they won't be opened again until the plant is running and needs maintenance years down the line. We are essentially sealing a giant steel time capsule.
But right before slamming that heavy door shut, inspectors obsess over one final detail: the flange face. That's the flat metal sealing surface of the door. They obsessively check it, because even a microscopic scratch on this metal or a tiny defect in the gasket means the equipment could leak highly pressurized, lethal chemicals later on. I mean, a flawless internal clean is completely pointless if the front door doesn't perfectly seal, right?
So, the next time you drive past a massive oil refinery or a power station, take a look at those giant steel towers and ask yourself, how confident are you that the hidden spaces inside were perfectly cleaned before the owner flipped the final switch? It really makes you wonder about all the invisible, microscopic details keeping our massive infrastructure running safely every single day. Thanks for joining me for this explainer.